Hello friends, this is the first tutorial from the Introduction to Python for Statistics and Econometrics course, and today we will learn some basic arithmetic functions and most useful mathematical functions for the subsequent calculations in statistics. So once you installed the Anaconda environment, you may find here the Jupyter notebook button, so press launch, and you will have a new window in your web browser. So then if you want to create a new folder, just press new folder. You will get the folder in the default catalog here. So I have the folder mathematical statistics here. Then I create a new Python 3 notebook, which is going to be the new script for working with the code. So I create a new file here. Then you have this environment. So first of all, here is going to be the name of your file. So let's call this tutorial 1. And the most important buttons: save, plus means that you create a new part of your notebook. So later you will understand how this works. Cut, copy, paste, which are the most familiar ones. So this is a navigation up and down from the different windows of your notebook. Run and stop. So the most essential and important things. Here you may find the window that you will create your pieces of code. So let's start with something very basic and simple. Just let's use Python as the extended arithmetic calculator. So I can write 1 plus 2, then I can press run, and then in the out you see that there is 3 and it creates a new line. As simple as it can be. If I write 1 minus 2, press run, I have the output minus 1. So the same thing works with the multiplication. Also, let's multiply 2 times 3. And then instead of click and run all the time, you can press the sequence of buttons Ctrl and Enter. So once I press Ctrl and Enter, I have the output 6. And the same way the division works, if I want to divide 4, let's say by 2, I can press Ctrl Enter and get this 2.0. So please keep in mind that there are two different types of numbers that Python treats. So you see that in 3 here, when I add 1 and 2, there is no decimals, while when I divide 4 by 2, there is 2.0. So those two are different types of numbers, and let's see how it works. So please remember this function. This function is sometimes essential. The function is called type. Once you press type and once you put there some number, let's say 2, and press Ctrl Enter, you have int, which is integer. So integer means that you have 1, 2, 3, 4, 5, or minus 1, minus 2, minus 5, or 0. So let's put minus 2 here. We will have also integer. Press there 0, that's also integer. But if instead of integer I put there something like the number with decimal 2.3, so then I have float, which is floating decimal, and so this means that we have the floating point number, which means the number with decimals. So sometimes this is crucial. Well, definitely that's not what we want while working with Python. So one additional thing I would like to show you. So there is some specific thing how to raise the number into the power. So for example, if you want to raise 3 into the power of something. Usually we have this, but this head doesn't work here, so you need to press 2 multiple signs, and then let's say 4th power. So that's going to be 3 to the power of 4, which is 81. So in the usual way, we can combine or group some operations with the parentheses. So for example, if you want to write 2 plus 2 multiplied by 2 without brackets, it's going to be 6. But if you put there brackets, so for example, you put there 2 plus 2 multiplied by 2, you will get 8. By the way, if you want to create a new line here, you see that these lines appear. You can press plus. You see the new line. If you want to delete this, you can create cut. Or instead of this, there are some hotkeys here. You can actually see that when you want to create a new line, where is that? You can press letter A. Is somewhere here. Insert cell above, you can press A. Insert cell below, you can create B, and you see that this is the same as pressing plus. And instead of copying, you can use just the button C in the command mode. And if you want to cut, X in the command mode. While if you want to run, you see that there is Shift and Enter, or basically Control and Enter the same. So you can cut it like this, or you can cut it simply, well, let's see the short cuts. You can delete the cell with pressing D. Plus D. Also works. Okay, nice. So now, from the very first day of working with Python, you must train yourself with given labels to different numbers, because all the essence of working with the programming languages while you are doing statistics, econometrics, and any other type of calculation is built on creating some objects and operating with these objects. So what I mean, instead of writing 1 plus 1, you do the following. You create, or you label number 1 with the name A, you label the number 2 with the name B, and then you write the operation that you want. For example, A plus B. So once you run this chunk of code, here you see that there is 3 appears, which means the following precisely. So create an object A, and this object A must have the value 1. Create an object B, and this object B must have the value 2, and then sum the values A and B. I can do even more. I can say that this sum has a label C, and then I want to see what is the value of this object. You see that that's the same. Once I don't put C here, it just creates me an objects, all these objects, A, B, and C, and keep silent. So it doesn't show me any output. If once I want to see the output, I need to put C here, and I will see what is the value of this label behind this label. If I press B, it's going to be A. If I press A, BA, you see that there is no such an object which is called BA. So by accident, I made a typo. So if it's A, it's 1. So now I can, for example, do the following: A plus B multiplied by C plus A multiplied by B, something like this. The result is 11. So this is the most simple thing you can do in Python. Now, usually we want to work with some arrays or collections of numbers. In order to work with these arrays, Python has a lot of possibilities. We will introduce the one that we will use throughout the whole course of statistics. This is called a Numpy array. So what is Numpy? Basically, the Python shell has some collection of essential functions. And if you want to do something fancy, something special, with the help of Python, you need to install or you need to invoke some special toolboxes called libraries. So Numpy is one of those libraries that has a powerful toolbox for working with some mathematical functions. So today we will learn two toolboxes with Numpy, and we also will learn SciPy, which is a very nice thing to work with some statistical functions. So how to call for this library. Before this tutorial, you must have made the installation of this library to your computer. So now you do something like this: import numpy. And there is some convention for people who work with Python. Instead of using the long name of this library, we write it like S and P. So what does this mean? It means that instead of when you want to call for this library, and when you ask Python to use this library, instead of always writing numpy, you will use np because it's just shorter. It has 2 letters instead of 5 letters. So now let's run this part. Let's create a new line, and on this line, let's create the following. Let's create the array of 6 numbers. So how to do this? We write np dot array, then we put the parentheses, then we put the square brackets, and then instead of square brackets, with the help of comma, I'm writing some numbers. Let's say 4, 3, 7, 2, and 10. 5 numbers. Okay, once I run this part of code, you see that the output is exactly this array with these 5 numbers. I can give a name to this array, so let's call this A, as simple as it can. Okay, so now if I call for A, here you see that A is an object, and this object now has the form of the array of 5 numbers. So what if you want to sum these numbers? So first of all, let's try to sum these numbers in the most simple way. 4 plus 3 plus 7 plus 2 plus 10. That's a simple way. Okay, so enter 26. Is there any shortcut for doing this? The answer is yes. So you can do the following. You can write the function sum, and then in parentheses, you can write the name of your array, A, and then once you run this, you see that the result is 26. So this is the sum. So let's call this sum, let's give it a name S. Okay. So now we have one object A, which is the collection of these numbers, and the other object is S, which is the sum of these numbers. Now, suppose we want to calculate how many, or suppose we want to count how many elements are in this array. So definitely we see that there are 5, but if you have a long array and you don't know exactly how many elements are there, so you want to have some special and nice function to calculate you the number of these elements. So this can be done with the help of a function which is called len. It's short for length. So len a, and you see that the result is 5. Okay, so let's call this n. Let's give it a name n. So now, if I want to divide s by n, what I will get the simple arithmetic average. S divided by n is 5.2. I can do this in one part of code. Basically, I can take all these chunks here in one line. And let's call this AVG. Okay, so now the code is silent. Once I exercise this, I can delete all these lines. And here, if I want to call the variable average, I have 5.2. Seems to be a little bit long. Can we do a shorter way to calculate this arithmetic average? The answer is yes. What is nice about these types of objects, Numpy arrays, is that they have some special methods. So you can do this in two ways. One way is to call the function mean from the library np. So this part of code means that you call first to the library np, and then from this library you invoke the function which is called mean. The same thing as here, but sum and length, they are the functions that are stored in the Python shell. So basically no need to use some special libraries. So there are built-in functions, while this mean, for example, is not built in. So that's why you want to call first np library, and then you call the function mean from numpy. And then as an argument of this mean, you put the a, which is the array of these numbers. And you see that the result is 5.2, which is the most simple way how you can calculate the mean of this Numpy array. Just simply np.mean a, and then you have a result. What else is good about Numpy array? Suppose that you want to subtract from each number a constant. Suppose you want to subtract from each of these numbers, let's say number 3. So let's call this b, which is 3. And then I want to do the following, a minus b. So what happens? Basically, Python is able to recognize that this is an array. It has 5 elements, and this is the constant. It has only 1 element, so therefore you need to subtract from each of these elements number 3. So the output is here, 104 minus 17. So this may help us with the following. Suppose we want to calculate the variance of this array. How can we do this? So what is the variance? This is the sum of squared deviations of these numbers from its average. So we do the following. We can take the sum of squared deviations, let's say, or as just SS, sum of squares. How the sum of squares would look like? We need to do, first of all, the function sum. Inside the function sum, we need to plug the square, which is now something to the power of 2. So now what is something? Something is the deviation of A from its average. So FVG is the average of these 5 numbers. So once I do this, I have this sum of squares. So let's run this part. Let's check whether it's correct or not. So SS is 42.8. Okay, nice. Now, if you want to get the variance, depending on what kind of variance do we want. So for example, we want sample variance, which means that we need to divide sum of squares by n, and we have n defined minus 1. So SS divided by, now in parentheses, n minus 1. So this is the sample variance. So I can give it a name, variance VRC, let's say. We have it here. Is there a simple way, as with the function mean, to calculate this sample variance? The answer is yes. So we can invoke from the library Numpy a function var, variance. Now I need to put here the array, but there's another thing. I need to write something like degrees of freedom. So let me check the syntax. Basically now you will see how it works. So if you suppose you forgot how to work with some function, suppose you don't know how to work with some function. So the first way how you can check is to ask for help. That's how it works. So you put the function, then question mark, and then enter, control enter, and if there is some piece of help, then you will see the syntax of a function. So basically it may look from the first glimpse very ugly, but don't worry. So A is exactly what we want, and then here DDOF. So that's what I was looking for. So it must be DDOF equals 1. If you want to understand what's the delta degrees of freedom, the divisor used in the calculation is n minus DDOF. So n is the number of elements, and by default it's 0. So DDOF is 0, so it means that by default this function divides by 0. By n minus 0, sorry. But I want to divide this by n minus 1, as it was here. So let's check how much is that gonna be. It must be 10.7. So let's compare this with VRC. It's 10.7. So you see that the variance might be calculated much faster. So these are two essential functions in order for being able to work with the first steps in statistics, since we studied these two functions. In your exercise session, you will see much more mathematical functions that are able to solve the familiar problems to you. Now, after this lecture, I would ask you to go through very short and simple quiz that will be based on these functions, on the function mean, on the function sum, on the function length, and so on. So please try, first of all, to reproduce these steps yourself, and then go to the quiz and solve some simple exercises. So see you next time.